right. Good evening, everyone. So today's topic is case statements in SQL. So first of all, welcome everybody. Thank you for joining. I'm here to talk about case statements in SQL. To start with the very basic, what is SQL? SQL is structured query language, as you all know. It's a very powerful language because it allows you to query relational databases where data is stored structurally. So structured data can be queried using structured query language. Case statement is just one functionality or one tool in your toolkit that allows you to query your databases in a very efficient manner. Okay. Having said that, so I came across this very nice quote by Sylvia Plath, which made me think that life is but just a series of case statements. I can never be all the people I want and live all the lives I want. I can never train myself in all the skills I want. And why do I want? I want to live and feel all the shades, tones, and variations of mental and physical experience possible in my life. Isn't that beautiful? So life is nothing but basically case statements, right? All right. Whenever, if you think back or when you're looking forward, planning something, you always prepare in terms of case statements. What if this happens? In that case, I'm going to do this. This is my plan B. What if this happens? Then this is what I'm going to do. What if I miss the train? Then this is my plan B. I'm going to take an Uber, etc., etc. So case statements are something that the human brain always thinks and calculates based on cases. And so think of the case statements in SQL also something similar. So what's our agenda for tonight? We are going to introduce case statements. We are going to look at some different types of case statements. We have simple case statements, we have searched case statements, additive, and then nested case statements. All right. So what is a case statement? So you already have an idea from the little background I gave you. Is case statement is basically SQL's way of handling the if-then logic. If this happens, then I'm going to do this. If that happens, then I'm going to do this. And if that happens, I'm going to do this. And if everything else fails, then at the end, I'm going to do this. So, that's the generic algorithm of a case statement. A case statement is followed by at least one pair of when and then statements. Think of it in terms of common English. If something happens, so instead of that, in a case statement, we specify when some condition is met, then do something. Say, and that do something could be basically assign some value to some variable or return some value in my query. Every case statement must end with an end. And that's how SQL engine or your database engine will know where to stop looking for the next case when you put an end. That I have these three scenarios. When this first condition is met, do this. When this second condition is met, do this. When the third condition is met, do this. And if none of the above are met, just return something default and end. And that's how you come out of that if then logic. All right. Any questions so far? Okay. All right, moving on. So let's look at a very simple example of a case statement. So for example, I'm, as you can tell by looking at this query here that I'm querying from a table called high school football players, and I want to see the name of the player and their year. And then I'm specifying a case that if they are in the senior year, then say yes, else say no, because I'm returning a field called is that person a senior? So if their year is senior, then return yes, else return no. So this is how I write my case statement. I specify the keyword case, and then I give the condition when some condition is met. What's my condition? When year equals senior. So when this condition is met, then return this. Else return this and then end. And then you can give it, this is just your aliasing your result set by giving that column a name is a senior. Any questions about a simple case statement? All right, we have an awfully quiet crowd today. Okay. All right, so let's look at the syntax, the formal syntax of a very simple case expression. So how would you go about it? Obviously, you have to first, your case statement begins with you specifying the keyword case, and then you give it an expression, and then you say when the first expression is true, then you give it a result expression. When this expression is, and you can give n number of expressions to compare. When this is the case, then do this. When this is the case, this, and so on and so forth. And then you give it when everything else fails, else the end result. And then you have to close your case expression with an end. So you begin with the case and you end with the end, and all your different cases or your different scenarios are between this case and end. Okay. All right, so let's look at this very simple case expression. I have a department table as an example. So this department table looks like it has an ID column, a name, the department name of this person, and their salary. So it looks like a pretty good data set. Now let's see, I have different kinds of departments. I have economics, music, philosophy, computer science. Well, computer science is better known as IT. So if I am to write a report and if I am to select, the department name and tell their category, I might do something like, if I come across computer science, then I don't want to show in my report as computer science. I want to show it as IT instead. So let's look at this. So obviously we will start with a select from department. This is the first thing that I like to do with any query is before I start writing the columns that I'm going to pick, I like to fill out the from clause, like where is my data coming from? And it is beneficial in a couple of ways. If I know where my data is coming from, when I'm working in SQL Server Management Studio, the IntelliSense picks up and it prompts, if I start typing the column names, it starts prompting the column names for me. So it kind of becomes easy if I'm writing a query from scratch. Besides, if you think about it, if instead of start typing select what columns you need, instead of that, if you focus on where you're getting your data from, it sort of helps you draw a plan in your mind of the query that you're going to write, right? If I know, if I'm going to start selecting data, let me first look at the table structure. What are the different columns that I see? What are the columns that I want to show in my report, and so on and so forth. So that's, it's just a good practice or my habit, like first determine where the data is coming from, meaning in your query, first determine the from clause. It could be a single table. It could be, you could be joining multiple tables to get the different columns that you want to show in your query. All right, having said that, so select, right now we are only dealing with this wonderful department table. So I'm just going to say select from department, and I'm saying select the department name and case. This is my expression. I'm evaluating this expression, department name. That's it. There is no condition, there is no nothing. And that's why I call it a simple case expression, because I'm just picking an expression and evaluating if this expression, when its value is computer science, then return IT, else return others. I could have added a few more items here, like when computer science then IT, when music or dance then art, or something like that. But this one example gets the point through, is that I'm evaluating this simple expression. I'm just looking at its value. If it is computer science, then return IT, else others. So what would this query return? It would return all the department names, and then it would return a new column called category, and then it will evaluate, is this computer science? It's not. So you will see the category is others. Everywhere you see computer science, instead of in place of category, it's going to return IT. All right. Any questions so far? Okay, I don't see, unless I'm missing any questions in the chat. Okay, great. There are questions there and they are being answered. Okay. So before we go to the searched case expression, let's take a minute and look at some practical examples of our simple case expression. I have now opened SQL Server Management Studio. I hope everybody can see it. All right. Okay, everybody can see it. I want to, before I start writing or talking about the case statement queries, I want to take a minute to, for those people who have not used SQL Server Management Studio before. So this is the tool, SQL Server Management Studio. If you look at this, Microsoft SQL Server Management Studio up top over here. This is the tool that is used by most database administrators, most people who are dealing with data to write queries in SQL Server. What it allows you to do is you can click on connect and pick what you're trying to connect to. Is it a database engine, an analysis services engine, integration services, etc. So our data is stored in a database. I have chosen database engine and I have connected to this database engine. If I expand this little plus sign on the left, it shows me the databases that are stored on this particular instance. And then this tool also allows you to, you can further expand and explore. It gives you it's a very nice visual tool that allows you to see, okay, these are all the tables in my database. It also allows you to expand individual tables, look at the columns, look at the keys of that table. You can even right click on a table and select properties and look at the metadata that's associated with that database. So for example, I know that this is my database. It was created on this date. It's right now, this is its current size, and so on and so forth. So it's a very handy tool, very easy to use. And when I connect to it, I can run queries against it. So this is what I have done. I am now connected to the sample retail database. Now in my sample retail database, I have a table called sale.orders. So let's see what the data in sale.orders looks like. Let's look at this data. All right. So I have an order ID, customer ID, order status, date, required date, etc., etc. Now let's see if I'm working in an office, a sales office, and my manager wants to see how many orders are there in the orders table, and what's the status of these orders. Now, if I go and give my boss this kind of report that, there are 30 orders with order status 4, 40 orders with order status 3, it does not quite make sense. So when I have to write a report, I want that report to be user friendly, so that if somebody who doesn't know the business logic that you have stored in your database, they should still be able to make sense out of that report, right? And that's data science. Okay, so let's write a query that will allow us to do that, so that I can map these order statuses to some actual meaningful values. So I'm going to select order ID and order status from my orders table, and I'm going to create a case statement where I'm going to evaluate this expression order status. I'm only going to evaluate what's the value of order status. When the value is 1, then it's pending. When the value is 2, it's processing. When it's 3, it's rejected. And when it's 4, then it's completed. If it is anything outside of these 4 values, then I use the else clause and I say, if it's not one of these 4, then just mark it as unknown. Okay, so I'm sure that, when the database got designed, somewhere there is a table that defines what the 1, 2, 3, and 4 stands for. But if you don't have that knowledge, what 1, 2, 3, and 4 stands for, and you want to prepare a report, this is how you would do it. You would use a case statement with a simple expression, and then you can use it to define the different cases or the different scenarios. So let's run this query and see what does it look like. So now I see that this order ID has order status 1, which shows completed. I see a lot of completed orders. Let's see if we can see any that are pending or any different from, okay. All right, so now I see order status, some of them are pending, some of them are processing, and I also see some of them are rejected. So now it becomes a very user-friendly report where I can go and search up, can you find the status of order ID 1608, and then I can go and look up in my report and say, oh, this order got rejected. I don't have to look at the table itself, go find 1608 and then look for order status 3 and not know what that means. Okay, all right. Another thing that I wanted to talk about here is you see how I have used the clause order by 3. So you can use specific column names when you are ordering stuff. I wanted to order by the order status description. You can either order it by the column name, or you can order it by number. So if I wanted to order it by the 3rd column that I'm selecting, my first order column is order ID, the second one is status, and the 3rd one is the one that is returned by my case expression, and I'm naming it order status description. So it gets ordered so that I see all my rejected orders at the bottom and I see all my completed orders at the top. If I choose to order it by order ID instead, let's change this to 1. And now if you run the same exact query, you will see a mix of, you will actually see, you should be, okay. So you see how now, because now it's ordered by order ID and not by the order status, you will see the statuses are scattered. I see order ID 69 was completed, but the order ID 70 here was rejected, and so on and so forth. So when you write reports or when you write stories, SQL queries, you are basically trying to tell a story about the data. So think about how you're going to present that. And the order by clause allows you to do that. You can order by one column, it will tell you one story, and you order by another. It basically gives the reader a vantage point, a different perspective of looking at the data, where you are emphasizing something versus the other. Okay, it could be the same data set, but because you have ordered it differently, it may tell a different story. All right. Going back to our slide deck. Now let's talk about a searched case expression. So we already saw the simple case expression. What does it do? It takes one expression and evaluates that one expression based on what the value is. It returns something that you have defined or depicted in your case expression. A searched case expression is very, very similar to a simple case expression, except you are putting some kind of condition. You can put a formula. You can put a condition like check something, check if this date is less than less than today's date. Check if this date is greater than 5 years after today's date, or check if age is less than 18. Then you can say not allowed. If the age is 18 plus to 21, then you can say, a young adult. 21 plus, mark as adult. And, there are so many examples. But point being, you are evaluating some kind of condition. It's not just a single column or expression. You are actually evaluating, applying some kind of logic or formula to evaluate a condition. That is called a searched case expression. Okay. Let's look at our same department table that we visited, and let's try to look at an example of searched case expression. So again, I have the ID name, department name, and salary. Now let's look at this. In this case statement, I'm specifying when salary is less than or equal to. I'm doing some kind of calculation. Like if the salary is less than or equal to 55,000, then mark it as low. If it is greater than 55,000 but less than 80,000, then mark it as middle. And when the salary is greater than or equal to 80K, then mark it as high. So here, this is a condition. This is a logic that is getting calculated versus what we saw in our previous example in the simple one. I'm just evaluating an expression. What's the value of this? And you're just comparing the value against, something that you have specified. Versus in the searched one, you are specifying some kind of formula, some kind of logic that gets calculated, and then the high, middle, or low gets assigned to your category. So when you run this query against employees, you will get the first name, last name, and based on their salary, which gets calculated, you will see whether it's high, whether it's low, or falls in the middle category. Okay, so everybody kind of sort of understand the difference between a simple case expression and a searched case expression. You could have any logic. If you're calculating a salary, if you could be calculating a date, like I mentioned, you could be calculating any other number like profit. If the profit has been, more than, or the cost, if the cost is greater than 5K, then, mark it as expensive or something like that. All right. So before we go to other case statements, let's go back to our SQL Server Management Studio. So for this one, let's look at a different table, which is the customer table. Now let's just look at what the customer table looks like. So I have selected the top 100 star. Star, when I say star, it means return all the columns. You can get the same exact result by naming the columns in your query as well. It is normally not considered good practice to write queries with select star. The reason being, when you do a select star, you are asking SQL Server to return everything. You are not filtering anything out. And if imagine if that table has millions of rows, then it may cause performance issues because you are just churning a lot of data when you really needed just maybe the name and the email addresses of your customers. You don't need to know their street or city or state, etc. All right. Anyways, we are just going to look at what our customer table looks like. And that's why I have used top 100, because if I'm just trying to get a feel of what the table looks like, I might as well do just with 100 rows. I don't have to pull the entire table by saying select star from this table. So if you say select star from a table and that table has 2 million rows, it will return 2 million rows for you. So that's why if you're just trying to look at and get a gauge of the data in your table, I recommend that you use the top expression and it will return exactly the top 100 or top 10 or top however many you specify in your query. All right. So in our customer table, we see the first name, last name, we see phone numbers of customers, email, street, city, state, and zip code. All right, so let's look at the query here. Now I want to write a query where if the email has, if a customer's email has something like gmail.com, then I just want to say that they have a Google account, they have Gmail. If they have hotmail.com in their email address, then I just want to return Hotmail. And then if they have Yahoo in their email address, then I just want it to return Yahoo. And for everything else, I want to return other as their email service provider. So looking at my customer base, I want to report how many users are using Gmail versus how many are using Yahoo or Hotmail or something else. And this is a perfect query to use a case statement. So what am I evaluating here? If I'm to know a part of the email, then I'm going to evaluate the column email. And then look at this condition. My condition is evaluating, does the email look like gmail.com? So as you can see, this ampersand sign over here, this is your wildcard. So it will ignore everything that comes before the @gmail.com. So if anything looks like this @gmail.com, then return Gmail. If anything looks like @hotmail.com, then return Hotmail. So you are evaluating this becomes your searched expression. This is your searched expression because you are actually putting some kind of condition that will first get evaluated and then a value will get assigned to your expression or your column that you're trying to return. So let's run this query. All right, so as you can see, I have the first name, last name, and it looks like for the people who are using msn.com, it's returning other. For folks who are using hotmail.com, it's again returning Hotmail. I see other, AOL and others. So it's evaluating their email and then returning accordingly if it's a Gmail, Yahoo, Hotmail, or other. Everybody with me so far? All right. Okay. All right, folks. Are there any questions? Does anybody want to speak up or are there any questions for me? I may not be. All right. Awesome. Thank you. Okay. Now let's go back to our slide deck to see what are we doing next. All right, so other case statements. So there are, I wish life were as simple as a simple case expression or a searched case expression. Like I just have to do 2, 3 case, check this, check this, check this, but that is not the case, right? Whenever you go for some, special offer or something, don't you feel like they make it so complicated? Like if you have been a customer for so long, and if you have spent this much amount of money, there are so many conditions that you need to meet to get that 10% or 5% discount, right? And you are like, okay, I thought I qualified for 30%, but I'm actually getting like a 20% or what have you. So, which means that the case expressions in real life are way more complex than what we have seen so far. And that is where the additive case expression and the nested case statements come into play. All right, so let's look at an example of an additive case statement. Okay, so for the additive case statement, I am going to use a table that I have. It is called sales summary. So let's look at what this table holds. All right, so this looks like a very nice table, which is basically storing all the information about my what brand I'm carrying in my shop, what's the category for that brand. Like if I have a brand called Acer could be computer accessories. Actually, let me pick another better example. So let's look at Bose. So Bose is a brand, and Bose can have products that fall in different categories. Like Bose can have Bluetooth speakers or speakers. They could have computer accessories and so on and so forth, right? So if you go to a Nike shop, they could be selling shoes, they could be selling you yoga pants or t-shirts or shorts or what have you. So Nike is the brand, and these are the different categories, right? Shoes, t-shirts, pants, and what have you. Then there is something called a model year. So for each brand, for each category, they could be having, there could be like model years. So for Bose speaker, there could be a model year 2019. Then they could have speakers coming in model year 2022, 23, and so on. And depending on what brand, what product, what model year, they could have different prices, right? The more latest an item is, the more expensive it's going to be. So now I have a case statement here. I'm saying that when I want to put some things on sale, but I want the sale cannot be as simple as I'm putting all my speakers on sale for 20% discount. No, that's not the case. So I want, if the category is speakers, then I want to give a 10% discount. But if the category is speaker and the brand is Bose, then I want to add another 10%. Okay. So if somebody buys a regular speaker that belongs to a different brand, then because it's a speaker, they will only get 10%. But if they buy a Bose speaker, they will get the discount, 10% discount for speaker, plus the additional 10% discount for being a Bose speaker. And then because 2018 is my oldest model year, I'm trying to get rid of all the old inventory. I want to say if somebody buys from my model year 2018, then I will give them an extra 10% discount. So look at the requirement, or think about the case. If this condition is, if it's a speaker, 10%. If it's a Bose speaker, plus 10%, meaning 20%. If it is a Bose speaker from 2018, then add another 10%. So if somebody buys something that satisfies all these three, they will get a 30% discount. If somebody buys something that only satisfies these two conditions, then they get 20% discount. And somebody who only satisfies this condition for their purchase will only get a 10% discount. Everybody with me? Yes, no? All right. Okay. So let's look at the syntax. So I'm saying select everything, and then I come up with the keyword case. case when category is speakers, then a 10% discount. And my case ends there. This case ends there because this is the only standalone condition that I'm offering on speaker. Is if it's a speaker, it's 10%. And that's why my case begins here and it ends here. But because it's an additive case statement, I'm adding something extra to the case. So I use the plus sign and then I define my next case. So then I say plus case when brand is this, then when brand is Bose, then add 10%, else nothing else, and end it right there. So you see, if somebody only buys something Bose, which may not be a speaker, they still get their 10%. Why? Because this is a separate standalone case right here. It's a separate standalone case, but it can also be added to the one before and the one after. And then I specify my third condition by adding this plus sign again, and then specifying my third case, which is the model year. And I say if the model year is 2018, then again 10%, otherwise nothing. So somebody could be buying any brand, any category, as long as they are buying 2018, I will still give them 10% because this case, which begins here and ends here, is still a standalone valid case. But you can combine these cases with each other, and that's an example of an additive case statement. Don't we see an additive case statement when we go for deals at Best Buy and whatnot? Right? There's always a condition. If you do this, then you can, give us your email and then you can get an extra 5% off and so on and so forth. All right. So let's go ahead and run this query over here. Okay. Now this is so much fun to watch. Let's look at this. So if the brand is Alpine and somebody is buying speakers 2018, so here I see two conditions are met. It's a speaker and it's 2018. So I get how much discount? 20%, because this 10% is getting added. Let's look at a 10% one. So look at this. Somebody is buying speakers, but they are not Bose and they are not from the year 2018. And so they only get 10%. Let's look at a 30% example right here. All right, so I see somebody buying Bose speakers with 2018 model, and look at that. They get a 30% discount. Isn't that cool? Everybody with me? All right, everybody understand the difference between how we started with a very simple case expression, where you give an expression, you evaluate what value is it, and based on what value it is, you come up with, what is it going to be replaced by. I see somebody has raised their hand. Do you want to speak? You can unmute yourself and or you can put your question in the chat window. Okay, am I missing something, chat? All right. Okay, moving on. Mustafa, feel free to put your question in the chat. Okay. All right. So where were we? We were on the additive case statement. So we were doing simple, a comparison of how we started with the very simple expression. Then we did slightly complicated, where we are evaluating some kind of condition. Salary is greater than 55K, or salary is between 55 and 80K, or salary is greater than 80K. So we are doing some kind of mathematical, condition evaluation. That's our second case, or second type of case expression. And then we see the additive ones, where you can have 2 or 3 standalone case statements, and you can do a mix and match based on if 1 or 2 or 3 or 4 or all of the conditions are met, etc. All right, and that brings us to the last type of case statement, which is the nested case statement. So the word nested itself tells you, if you have done any kind of programming language, nesting is very common. It's and I always like to give the analogy of when we talk about nested, I like to give the analogy of that movie, Leonardo DiCaprio. I forget the name. It's a dream within a dream within a dream. What was that? Oh my gosh, I completely forgot the name of that movie. So anyways, it's one of my favorite ones. Leonardo DiCaprio is the lead actor in that movie, and it's about how Inception. There you go, exactly right. Thank you. So Inception is that movie. So how they nest the dream within the dream within the dream. So think of nesting in any sense when you talk about a computer language. It's exactly the same thing. You go in one step and then you go further down one level and then further down one level. That's called nesting. So a case expression, think of it as forking, right? If I say, if I go straight from my house and then I take a right, I can again go either left or right. So that branching itself gives you, that branching gives you the option to nest an expression, right? Or write different cases. Like first you take a right, then you can either do this or that. You can go to a college of arts and sciences, and there you can either do computer science or you can study like pre-med, you can study medicine, or you could do music. If you study medicine, you can either go into nursing or you can become a doctor, or you could do, so you see how you can do nesting one level after the other. There are again so many examples. Okay, so let's look at, I have this query, which is slightly complicated, which I prepared for you, and I'll tell you why it's complicated. It's complicated because it uses something called CTE. I see Mustafa's question. Is this plus sign mathematical operation? Yes, it is. That's why it's called additive, because you are adding one condition, and that's why when we go back and look at this, I'll run this again for you. So you see 10%, 10%. It's, if you look at the discount, it's actually adding your discount. It's actually a mathematical operation which adds this 10% to this 10%. So you see where 2 conditions are met, it added the 2 and you get 20. Where 3 conditions are met, you see 3%, 30% discount. So it's actually you could try. If you want to reduce the discount, do you replace? No, if you want to reduce the discount, you would reduce the discount here. Like when the brand is Bose, I don't want to give a 10% discount. I just want to give a 5% discount for the Bose. So here, this is where you would do your discount. Okay. All right. Does that answer your question, Mustafa? I hope it does. All right. In the interest of time, I'm going to move on and talk about the nested case statement. And I was talking about why it is complex, because I have used another construct called a CTE. It's a common table expression. Again, when we offer our SQL course, we study or explain all these different tools in your toolkit in much more detail. So CTE is something, think of it as a temporary table, which will bring the data that you want to use into a temporary space so that it becomes easy for you to join and write complex queries. So I have this CTE over here, and then I'm, instead of focusing on this CTE, let's focus on our nested case statement. Okay, so look at this. If the city is Austin, Boulder, or Cape Coral, then so this is my first level. I'm first checking what is the name of the city? Okay, where is that customer living? Is the customer living in Austin, Boulder, and Cape Coral? That's my first level. If that's the case, then look at the order count. If the order count is greater than 5, then look at how much did they spend. Did they spend a total was more than 5,000? Then give them 20% discount, else give them 15%. So you see, I have 3 levels of nesting here. I first check if the customer lives in a certain city or a set of cities. Then I check how many orders have they placed. Did they place more than 5 orders? Then I check the total of, so somebody would have like come in and bought like 5 Snickers, or 10 Snickers 10 different times. So even if their order count is 10, they are not spending more than $15, right? But somebody would have possibly bought 4 items, but they spent like $75 with those 4 items. So it may, it varies. And that's why you go in this nesting, you check one item after the other. All right. So if we saw this first case, the next one is first level is city. I'm checking it in 2 different places. Next level is I check the order count. If the order count is greater than 5, then I want to give them the maximum discount. But if the order count is greater than or equal to 2, then I go into another nested loop. I check if the total spent is greater than 2,000, then I'm giving them 18% discount, or I'm giving them 12% discount if it is not. And then I end my first case statement here. And then I do similar thing for my next one. For customers living in Atlanta, Boston, and Charleston, I'm checking second nested level is if the total spent is greater than 3,000, then I'm giving them 15% or I'm giving them 10%. So look at how the nesting is happening. Why would I want to write a query or why would I want to give a discount like this? The requirement is because maybe customers living in different cities, they have different income level. And so keeping that in mind, I want to offer some kind of discount that makes sense to customers living in all the cities. I cannot just take like one, what do you call it? Like one stick and measure everything with that. And some of the other things or variables that come into play may also be where are most of my customers situated, right? So if I have most of my customers living in, say, Atlanta, Boston, or Charleston, I may give them extra discount even if they have spent only $3,000 because my customer base is large there. So just some background. But anyways, let's run this query and see if this makes sense. Let's run the entire query so that it will actually return some results for us. Okay. And see, this is the nice thing about working with SQL Server Management Studio and SQL Server is if you do something that SQL Server does not like, most of the times it gives a fairly good reason why it doesn't like what you're doing. It will give you a very nice error message that explains to you what did you do wrong. So in this scenario, what I did is I ran this query, I defined a CTE, and then I did a select statement, but I did not include the from clause. And that's why SQL Server is complaining that the common table expression is defined, but you did not use it. You forgot to use it. So now I have to go select my common table expression. I have to select it and run the entire query, and then it should return some result. All right. So let's look at our nested query and see if it actually makes sense. So my customer living in Charleston, that means it should fall in this loop or this expression. This first level is the customer lives in Charleston. What is their order count? Now, in this case, I'm not worried about the order count. I'm just worried about total amount that is spent. So did they spend more than 3,000? Now this customer, they only spent 2,200 something. So they did not spend over 3,000. So that means they fall in the else. And so I'm only giving them 10% discount. So their discount is 10. Okay. Let's look at a different example of 20%. So look at this customer ID 3. This customer lives in Cape Coral. So Cape Coral is my first level. It satisfies this condition. So I go and check the next one. Is their order count greater than 5? Yes, their order count is greater than 5 because this customer living in Cape Coral has placed 13 orders. Okay, good. So I go in the next level or the next, what do you call it? My dream is within a dream, and then this is my final level. I check if the total that they have spent is greater than 5,000. And oh my gosh, this person has spent 11,000 plus dollars. So in that case, this evaluates if this is greater than 5K, then 20%. So look at that. They do get 20% discount, which is the highest discount that I'm offering in my shop. Any questions so far? So does it make sense? You can write some fairly complex queries using nested or additive or even a combination of the two case expressions. So you see, we learned 4 different types, but we learned them individually. You could also mix and match all these case expressions and try and write reports or queries that are fairly complex. Is everyone with me? All right. Okay, so a quick recap of what we have learned today. We covered the topic of case expressions. Case expressions are the equivalent of if, then, else logic in any programming language. We saw 4 different kinds of case expressions. We started with the simple case expression, where we evaluate an expression, and based on that value, we return something. That is, and that's my cue that we have only 5 more minutes. The second one we saw was, anybody? The second one that we saw was what kind of case expression? So we saw additive, we saw a searched case expression. The searched case expression allowed us to put some kind of formula, a logical statement that could be evaluated, and then the value be assigned. The third kind we saw was an additive case expression, where it allows us to specify standalone different cases, and we can mix and match or combine these, actually add them, the additive case statements. So that was our example of the additive case statement, which allows you in the syntax to use plus. And then you can define each case separately. Like we saw, the case begins with the keyword case and ends with the keyword end. So this is my first case, standalone. It begins with case, ends here, begins with case, ends here, second case, and then this begins here and ends here. So 3 standalone cases, but I used additive expression to combine them so that they are evaluated, and the result is based on all 3 of them getting evaluated and getting added or not based on if the condition is satisfied. And then last but not the least, it was the nested case statement, which the concept is fairly simple, but it allows you to write fairly complex scenarios in your queries. Is you first evaluate something. If that is true, then you come down to the next level. If that is evaluated true, then you come down to lower and lower levels, and you can do any number of nesting based on your requirement. All right. Having said that, I have really enjoyed this last 1 hour talking to you about case expressions. I hope you have enjoyed the case expression session as much as I did. And again, I would like to insist that in our cohorts that we offer, we not only cover, topics like case expression, we cover much, much more in a very short amount of time, so that by the end of these cohorts, you feel like you know enough to be dangerous. Okay. With that, I will open the floor. We have 3 more minutes left. If anybody has any questions, any comments, please feel free to speak up or put your questions or comments in the chat window. We have a couple more minutes left, so I want to take this time to talk a little bit about, let's go back and visit SQL Server. So SQL Server in general is, Microsoft's product. It is extremely powerful, and they have the Enterprise Edition comes with some very cool features. The Developer Edition is free, and it has all the features that Enterprise Edition offers. So you could go to the Microsoft website and download a Developer Edition on your personal machine or laptops and try your hands on it. It has all the same features and it's completely free. So I definitely recommend that you download, SQL Server. It comes with this client tool, which is SQL Server Management Studio. And, you could import, Microsoft ships some of their trial databases like AdventureWorks. It will come in with the built-in tables and, some data that you can start writing simple queries and sort of teach yourself some of the basics of structured query language. And I hope you have enjoyed. It's 8 p.m. I will say goodbye. Thank you so much. And I'm looking forward to seeing you in more sessions. Thank you.